Hello, everyone. I'm Longjia from TCL Research. So our team was focusing on the electrically driven quantum dot light emitting diode, which is also called QLED. So it is my pleasure to join this online meeting. And today I'm going to talk about the progress of the IJP-QLED display in TCL. So first, I'm going to talk about the evolution of the quantum dot for display. So at the beginning, the QD films is only using for backlighting, as shown here. And then the QDCF technique has been developed to replace the traditional LCD color filter with the quantum dot film to get a better color quality. Then Samsung gave the idea about the QD OLED. So for QD OLED, they are using red and green QD film as the color filter and using a blue OLED as the light source. So all these techniques I mentioned above are using the QD photoluminescence properties. But in the future, we believe the full series RGB QLED is the future of the QD display. Then in order to make the commercialization of QLED happen, TCL chose the inkjet printing technique as the mass production tool, and we think we have to concern on 4 aspects. First is about the QLED materials. So for materials, the first thing is about the QD materials. So we need to design the QD materials based on the EL requirement, especially for the blue one. At the same time, we need to pay attention to the charge transporting materials like zinc oxide. And the second thing is about the device. So of course, we need to push the performance of the device to a higher level, but at the same time, we also need to do it in the mass production feasible and low cost way. So to compromise these 2 things is quite important. And third thing is the printing technique. So as I said, we choose the inkjet printing technique as the mass production tool, but this technique is still not mature. It still has a long way to go. So we need to improve the inks, the printing technique. We need to find a way to evaluate the film, and we also need to pay attention to the fabrication process flow. And the fourth part is about the mass production development. So for these areas, so I want to emphasize that instead of the competitors, we think the IJP-QLED is kind of an upgrade of IJP-OLED. So the IJP-QLED can inherit the key generic technologies from the OLED, like the oxide backplane, the printing equipment, the modulus, and et cetera, et cetera. And also, these 2 techniques can share the mass production experience and the industrial chain in the future. So that's why TCL's strategy is we will push the IJP OLED commercialize first, and then the QLED will follow. So we think that after we can make a big progress in these 4 areas, and then we can talk about the commercialization of TCL, of the IJP QLED. So for the following part of my presentation, I'm gonna show the achievement of the TCL in this area, and gonna talk about the challenges we have to conquer in the future. So first is about our works towards the mass production. So in the past couple of years, TCL basically did 3 things. The first thing is to solve the blue lifetime issue. So it is well known that the blue lifetime issue is a big challenge. So it is really hinder the commercialization of QLED. So TCL put a lot of effort in this area in the past couple of years to change a lot of things, to change the materials, find the proper structure, so and find the decoded mechanism, decoration mechanism. So by doing so, right now we push our blue lifetime 2 orders of magnitude higher. You can see from the table. And right now it's in the same order of magnitude of the blue OLED. The second thing we did is to find the right structure, right QLED structure. So if you go to search the literature, you can find a lot of good data from the literature, but most of these data are based on bottom emission device structure. But for mass production, we need to use the top emission one to get a bigger to get a bigger size of the pixel, to have a big lightness. So that's why TCL put a lot of effort in this area in a couple past years. And right now, all of our data are based on top emission structure.